right, my friends, so now we're going to do is we're going to build a flock with 4 pullets and hopefully get 4 chickens, but at least we're going to look at all the possibilities of what can happen if you buy 4 pullets. So which 4? Well, we've already met Nancy, Marge, and Mary, and now we're going to meet Bertha. Bertha is my dad's mom, taught me how to trim roses, plant strawberries, and the finer points of being a German, French, Canadian. Anyway, so those are our four birds that we picked up. Now what we're going to have to do is we're going to have to build the distribution. So let's come on over here, and I'm going to start by going X equals the number of girls, just like we did up top. Exactly the same as we did on the board before. I want to center everything. We'll do this bold. And with the probabilities. Okay. All right. We're looking pretty good so far. Now, since we're buying 4 birds, that means we can either have no girls at all, which is going to be very, very rare. 1, 2, 3, or 4. Those are the options. Right? As far as the probabilities go, I think we can establish the end caps like we did before. Like, for example, the chance of all of them being girls. Okay, the chance of all of them being girls is going to be, I'm going to be a little fancy here. I'm going to go 0.9 to the 4th power. Because that's exactly what it is. It's 0.9 for Nancy, 0.9 for Marge, 0.9 for Mary, and 0.9 for Bertie. And that comes out being about 65.61. Well, it comes out being 65.61%. All right, so similarly to that, let's do the 0 case, which is going to be equals 0.1 to the 4th power. All right, and that's 1 in 10,000. So both of these numbers should make sense. It's getting harder and harder and harder to get either all girls or all boys, which means it's getting easier and easier to get a mix in the middle somewhere. And this is, you'll see this more and more as we go through the remainder of this course, the idea of regression to the mean. Getting all of either girls or boys is going to be less prevalent as we move forward than getting some mix. Now, let's continue. My mouse is stuck here in the 1 spot. Let's deal with the 1 spot. Now, what I'm going to do first is I'm going to start like we did on the board. If I've got 1 girl, that means it's 0.9 times 0.1 cubed. Now, before I hit enter, I want you to look at that. The reason that makes sense, on the board I wasn't using exponents like I'm using here, but we totally can. 0.9 is the girl, and then the 3.1s are the boys. So that probability is 9 in 10,000. Now, you know that's too small. So how do we adjust it? Well, we got to think. When I wrote it as 0.9 times 0.1 cubed, that was suggesting that the first bird was a girl and the other 3 are the boys. But what does the first bird mean? Well, instead of saying it as the first bird, say it as one of the birds. So who's the 1 girl? Either Nancy is going to be a girl, or Marge, or Mary, or Bertie. So what we have to do is we have to adjust this by multiplying it by 4, because there actually are 4 different possible ways for one of the birds to be a girl and the other 3 to be boys. Okay, similarly, I think we want to look down at the 3 case now, right? The 3 case. So this is going to be, we need 3 girls, so that's 0.9 cubed, times 0.1. So that's 3 girls and a boy. But again, that's not right. 0.0729 is not right, because there are multiple ways we can have 3 girls and 1 boy. As a matter of fact, let's look at the girls again. Except, instead of counting all the ways we can have 3 girls, let's just count the number of ways one of them can be a boy. And pretty soon you're going to realize, oh, it's the same 4. It's exactly the same 4. Okay, friends, in case you didn't like the way I counted the boys instead of counting the girls, and I said it's easier to count the boys because that way you don't have to group them in 3s. So I decided, okay, let's not do that. Let's actually do it like this instead. Let's group them as girls. So what I'll do is I'm gonna just put a little check next to each group. I have 4 different colors here. So one group, if we pick 3 girls and leave 1 boy behind, Nancy, Marge and Mary could be the girls and Bertie could be the boy. That's one way to group them. Another way would be Marge, Mary, and Bertie. Okay, that's a different group of three girls. Some of the girls are the same in the groups, but since you have at least one different, it's a different group. How about we go Nancy, Mary, and Bertie? That's a different group, right? It's a different group. And then what color? I haven't used purple yet. And then we can also have what? Nancy, Marge, and Bertie. Now, if you take a look at the groups we've got so far, there aren't any more. If you try to create another group of three, you're going to recreate one of the ones you already have. And you can I'm going to give you a preview of what you'll be doing on the homework. You see how each girl is in 3 of the 4 groups. That's why me counting the boy was okay. Because by counting the boy, I was effectively counting where the hole is in this group. So I just wanted to make sure that I wasn't trying to pull a fast one on you. Mathematically, counting how many groups of 3 there are is the same as counting how many groups of 1 there are when you only have 4 things. More on that to come. All right. So now we've got most of this distribution figured out. As a matter of fact, if we add it up, we know this remaining probability right here has to be whatever is left. Okay, it's got to be 4.86%. That's the chance of getting 2 and 2. Actually, what I'm going to do is 4.0486. I'm going to type it as a static value, and you're about to see why. Okay. Now, we know this probability is 4.86%, but what I want to do is I want to calculate it like we did in our second project. So what I'm going to do is I'm going to start exactly the same way, 0.9 squared times 0.1 squared. Now, that you can tell is not right for 2 reasons. First, this doesn't sum to 100%. And secondly, that doesn't equal that. So the question then is, what do you have to multiply this to get to this? Well, we can do it kind of trickily by taking that and dividing it by this and coming up with the number 6. And then we have to ask ourselves, why 6? Well, let's take a look at the girls again. And this is going to be a little bit more challenging because we have to figure out all the possible ways that we can pick 2 of these 4 birds to be the females. And conversely, therefore, we also leave the other 2 behind to be males. It doesn't matter which way you look at it. That's one of the nice things about this. Okay, well, let's start. Let's pick both of Jen's grandmothers, Nancy and Marge. So there's one of the 6. How about Nancy and Mary? There's another one. How about Nancy and Bertie? There's another one. So there's 3 of them right there. Now, in all 3 of those, I assumed Nancy was going to be one of the girls. But Nancy doesn't have to be one of the girls. She can be one of the boys. So let's go through it again. Why don't we pick Marge and Mary? So there's a 4th way. And then how about Marge and Bertha? There's a 5th way. The one last way is going to have to be Mary and Bertha. And there's the 6 ways, which means we can delete all of this and simply come in here and multiply this by 6. And then look at that, my dear friends, we get a sum of 100%. And that is pretty awesome. I can get some more decimals here so we can get some more precision if you need it. Now, looking at that distribution, you can see there's quite a bit told to you by these percentages that are in there. For example, roughly 2/3 of the time, you're going to get all girls. Everything else is going to be at least one boy somewhere. But look at the probabilities. Look at the probabilities. I mean, you've got almost no chance, a 0.01% chance, 1 in 10,000 chance that you're going to get absolutely no girls and all roosters. So again, just like 1 in 1,000 from the previous flock of 3 birds was hard to swallow, 1 in 10,000 is exponentially harder. The 3-girl situation is actually, that probability is getting somewhat high, isn't it? I mean, 29.2%. That's free. That's almost 30%, 3 times out of 10. So you can see that about 95% of the time, if you buy 4 pullets, you're going to be getting either 3 or 4 girls, which means you might run a chance of getting a boy. And of course, you're going to correctly tell me that there's always a chance you're going to get a rooster, but the chance of getting no roosters is shrinking exponentially. So you see, you get a lot of information from these distributions. 2, 2 and 2, nah, not very likely. 1 and 3 and 0 and 4, even less likely. But this is starting to tell us something up here about the likelihood of these things. And even though a 90% chance of one pullet being female seems pretty high, repeatedly drawing that 90% is going to be harder and harder and harder to do with the more chickens that you add to your flock. All right, let's do one more video kind of wrapping up everything that we learned today.